Okay, dear friends, so we are solving or revising now general physics today, thermal physics and physics of waves for uh, paper 4. And right now the paper in front of us is May-June 2023, paper 4, variant 3. One thing which we teachers are from the beginning, we are telling you people, see how much time is allowed for this paper. That is 1 hour 15 minutes, and if we convert it into minutes, it will be simply 75 minutes. 75 minutes. But now see how many marks? Marks are 80. It means here we are not supposed to solve our paper accurately. We are also required to solve our paper accurately as well as quickly. So fast and accurate is the requirement for this Cambridge paper 6 for IGCSE O levels. And also one thing more again, we are no more going to use the value of G, which is acceleration due to gravity or gravitational field strength. It is no more 10. We are only going to use it 9.8 meters per second square equal to small g, which is acceleration due to gravity or gravitational field strength. Now, let's start our first question. Figure 1.1 shows a balloon filled with helium gas. The mass of the balloon is 120 kilogram. Mass is given. Calculate the weight of the balloon and show your working. Very important. If you are not showing the working, even your answer is correct, you are not going to obtain the full marks. Full mean you are not going to get 1 mark, because there is no 0.5 or 0.25 or 0.75. It is 0 or 1 in this case. So first of all, we know very well the equation for weight. W is equal to mg. Mass is 120. Value of g is 9.8. So it means answer will be 120 times 9.8. It is equal to 1176. Now 1176. You are not supposed to write this all answer as it is. The reason for that, we cannot write 4 significant figures in our answer. So either you can write here 1180 Newton, or even you can round it off to nearest 1200 Newton. So I will prefer to write 1100 Newtons, by the way, 1180 Newton. Okay. Then my dear friends, the resultant force on the ball is 54 Newton. Force is given. Show that the mass of the ball is 0.45. No problem. Resultant force. So from Newton's second law of motion, F is equal to ma. So if we make A as the subject of equation, it will become force over mass. Force is now 54 and mass is 120. It is given to us 120. So when you will simplify exactly, you are going to get 0.45 meters per second square. Okay, let's confirm it. 54 divided by 120, it is equal to 0.45. So meters per second square. Meters per second square. Okay.
Still have a question.
Yes, my dear.
In the upper question, like, do I have to convert it, or I mean to like round it to 1180, or it can be 1176?
No, it cannot be 1176. The reason, Maria, maybe you missed that point. I told already. Our final answer, I'm talking about our final answer, it must be either 3 or 2 significant figures. Now if you ask me, in this case 3 figures are there, significant 118 and here 2. If I'm writing 1176, these are all significant, so 4 significant figures are not allowed in our final answer, by the way.
In all the questions?
In all the questions,
Okay.
Okay, so remember it. Means 0 zeros, whatever the zeros at the end, we will not consider them as significant, by the way, in this approach.
Yes, okay.
Nice. Let's move forward. Now, the balloon accelerates upwards from rest. if it accelerates upward from rest, so its initial velocity, which can be represented by the letter u, is 0 at this acceleration and for this much time. Calculate the velocity of the balloon after 8 seconds. So it means they want us to calculate the final velocity. Now, how to calculate the final velocity? We can do one thing, that let's use the formula a is equal to v minus u over t, equation for an acceleration. Now let's cross multiply and we will get v minus u is equal to a times t, because v minus u times 1, it will be same v minus u. A times t, it is equal to at. Now make v as the subject of equation. Here it is minus u, on other side of the equation plus u and at. Now u is equal to 0, a is equal to 0.45 and t is equal to 8. So as you will simplify, answer will be 3.6 meters per second. 0.45 times 8, 3.6 meters per second. So velocity is equal to final velocity 3.6 meters per second. Calculate the distance traveled by the balloon in the first 8 seconds. Distance traveled by the balloon in first 8 seconds. Now, here a very common mistake done by the student, v is equal to distance over time. Then make d as the subject of equation, it is equal to v times t. And then it is 3.6 times 8. Answer comes to be 28.8 meters. And they are very happy. They are saying we did the job, but this one is wrong. This one is wrong. Why wrong? No, be attentive here. It was not a case where the body is moving with constant velocity. It is moving with constant acceleration. Okay, we can say an acceleration is 0.45 throughout. Initial velocity is 0, final velocity is 3.6. It means body is not moving with constant velocity, and we know that actually the formula is V average is equal to total distance traveled over total time taken. So if again we simplify it by cross multiplication, making d as the subject of equation, so V average times t. And further we can write d is equal to 0 plus 3.6 divided by 2 times t, which is 8, and as you will simplify it, answer will be 14.4. So you can write here 14.0 or 14 meters. Now this one approach is okay. So always remember, this writing simply v is equal to d by t is not the correct idea. It is v average. So average, how we are calculating? Sum of the quantities divided by the number of quantities. Now here quantities of the velocity, we were having two values. One was 0 and the other one was 3.6. So sum of 0 plus 3.6, sum of the quantities over the number of quantities, how many they are? 2. So we simplified 14.4 meters, or we can write it simply 14 meters. Even 14.4 meters is workable. It's okay. 3 significant figures. Now please, if you have any idea, any query, feel free, you can ask me.
Mister, I still didn't get the question. I didn't understand, like, why did we solve it in the other way?
Other way? What other way, doctor? Okay, tell
Like,
me.
not the first one.
Yes, please, yes, go ahead.
Like, why isn't the first one the right one?
First
So,
one, it is simply talking about this v is equal to d over t. So then why I am using v 3.6? Why I am not using v as 0? Both are there. So why only v 3.6? Why not v is equal to 0? So we should use 0 also. Then we should say that distance traveled is 28.8. So there was a reason, Muhammad Tark, you are also asking the same thing. There is a reason I have chosen this paper, because many times even my colleagues solving, who are not that much experienced, solving this question wrongly even. Now see, I will give you one evidence to prove this. Okay, now this is velocity time graph. Velocity in meters per second. Speed time graph, you can say time in seconds. initial velocity u is equal to 0 and final velocity as we have calculated, that is 3.6, and the time taken for this journey, that is, let's suppose here 8, here it was 4. Just I'm roughly writing these values, I'm choosing the data which is given there. Now what do we know? If it is a speed time graph and we are asked to find the distance, so what we are doing, distance is equal to area under the graph. And in this case, Mariam and Mohammed Tariq both, in this case, it is 1 over 2 times base into height. So this is 1 over 2 times what is base, that is 8. And what is height, that is 3.6. And when you will simplify, it will be 14.4 meters. Are you doing bus 8 times 3.6? No, not at all. So this is the convincing proof that when we are calculating distance from the graph even, so we are not using only final velocity, we are using average velocity. You may think, sir, where is the average velocity now? Even there is average velocity in a hidden way. See, 0 plus 3.6 divided by 2. So see, this is 3.6 divided by 2, 3.6 here and 2 here to divide. And 8 is simply the time which is on x-axis. So this is one way. Okay, another way, that's what I told you already. If in the question it was said that body is moving at constant velocity of 3.6 meters per second, calculate the distance traveled for 8 seconds. So then what was the shape of the graph to be? In that case, shape of the graph was going to be like this: v in meters per second and time in seconds, and it was going to be like this. Now here time is 0 here, and let me say time is 8 over here, and here velocity is what, 3.6, here velocity is what, 3.6, and here velocity is what, 3.6. Alatul, it's constant. In such cases, when the velocity is constant, then distance is equal to speed times time. Even here you can write average, and in that case even average will be equal to still 3.6 times t, and what is that, 8. And in that case the answer was going to be 28.8 meters. Why average is same? Because average means 3.6 plus 3.6 divided by 2. Still the answer is what, 3.6 meters per second. So this idea will be workable only in case if the distance traveled is asked to calculate, but the body is moving with constant velocity. Here body is not moving with constant velocity, so we are supposed to calculate the distance traveled by making use of the average velocity. Please comment on this, my dear friends.
Yes, okay.
Mohammed Tariq, please comment, my dear friend. So there was a reason to choose this question or this paper. All of a sudden it was not 4-1, 4-2, I choose 4-3. I have chosen 4-3. Anyhow, now let's move to the next question. Question number 2. Define pressure. It is force per unit area. Simple. Definition. Describe how pressure in a liquid varies with its depth and with its density. Variation with depth and variation with density. Pressure, here formula, it means force. Pressure is equal to force per unit area. And this is talking about a liquid, and pressure in liquids, P is equal to rho GH. This rho, this is read as RH rho, and it represents density. This is representing height, in other words depth, and G is the acceleration due to gravity. And we know one thing very well, we discussed it, that in liquids, number 1, pressure is directly proportional to the density when the depth is kept constant. If you are in a swimming pool of fresh water at a depth of 3 meters and you are in a swimming pool of seawater at a depth of 3 meters, so then in the seawater you are going to experience greater force, so greater pressure as compared to fresh water. The reason, because the density of the seawater is higher than the density of fresh water. Than the density of what? Fresh water. So now the one thing. Then another thing, number two, that pressure is directly proportional to depth when the density is kept what? Constant. Like you are swimming in a swimming pool of fresh water, you are at a depth of 3 meters, and then you are going further down and you are at a depth of 5 meters. So when you are at a depth of 5 meters from the surface of the liquid in the freshwater swimming pool, so at 5 meter depth you will be experiencing greater pressure as compared to 3 meters depth. The reason, as the depth is increasing, so the number of water molecules on your body, above your body, they are increasing. So more number of molecules, more mass, it means more force, and more force means more pressure. And one example is coming in my mind, maybe 2 years back or 1.5 years back. 5 people in UK, through some company, they went down to see the remains of the Titanic by using a submarine, and 2 Pakistani father and son were also there in that trip. And when they were down, so the submarine, it was burst due to the tremendous pressure. They went deep down, and then it was not able to cope the pressure of the water, so that submarine, it burst, and all 5 people, they were dead in that incident. And so as scuba divers, even when they are going deep down and diving deep down into the water, into the oceans, so they are not using the simple dresses or like this, so they are having particular special dresses for that purpose, to cope the pressure, high pressure, tremendous pressure of water as they are going deep down. Even right now, all of us we are in the ocean, but ocean of air, and we are at the bed of the ocean of the air. So at the ground, the pressure of the atmosphere on us is maximum. The reason, the depth of our bodies into this ocean of air is maximum. As we are climbing up, rising up, either in the aeroplanes or you are a mountaineer and you are going to surpass the Mount Everest or K2 or some other higher peaks all over the world, so you have to carry the oxygen cylinders with you, the pressure decreases. So as we are going up, so the number of molecules pushing us, they are becoming less, and so on. You can think less mass, then less force and less pressure. So pressure is directly proportional to depth. So easily we can answer this question. My purpose is not only to solve these questions, but I want to give you information, and this will be recorded so that you can re-watch and confirm it. Otherwise you can ask me again. So now we can answer this question. Describe how pressure in a liquid varies with its depth and with its density. So variation with depth. So you can say, as depth increases, pressure also increases. And what about the variation with density? Because directly proportional, so again we can say, as density increases, as density increases, depth as the density increases, pressure also increases. Or simply you can say pressure increases with density. That's also okay, shortcut. But anyhow, now I have written, so as density increases, pressure also increases. Now my dear friends, next is state 2 energy resources for which the sun is not the main source. Yes, Mariam, correct. But they want 2. One is geothermal. Geothermal energy. There are 3 in your syllabus. Number 2 is tidal, which is due to the tidal and wave. Tidal energy, which is due to the pull of the moon. Sun has to do nothing. So they did not ask for third one, but I would be like writing it there. So third one is nuclear energy. So these are the 3 sources of energy which are not depending upon sun. Hydroelectric power, no, that is depending on sun. And why hydroelectric power? It is just by the water stored at higher level. How the water is stored at the higher level in a dam, that is simply radiations from the sun evaporate water from water masses. And when I'm saying water masses, it means oceans and lakes and rivers, everything, so forming the clouds. And on condensation it causes rainfall or snowfall in cold weathers, and then that water is rushing down into the dam and stored over there. And in summer, if it was snowfall in winter, so in summer that snow will melt over the mountains and the water will be again flushing back into the, like flushing flood situation will be there, very fast flow of water into the dam, and water is stored over there. And then that water falls on the turbine, and the turbine is turning the generator on and electricity is generated. So basically the source behind the hydroelectric power is solar energy. We cannot say that it is, no, sun is not main source. And the main sources on which are dependent on sun: fossil fuels, wind energy, biomass, then this hydroelectric, and one more I'm forgetting. And what is that? Really, one more is there and I'm forgetting. Yeah, solar energy itself directly. So these are the 5 sources which are dependent on solar energy. State and explain whether each of the following methods of electrical power generation is renewable. And my dear friends, you can, whatever I said just to you people now, you can open chapter number 7 in the work, energy and power. Key points I have provided you, you will find these answers over there. So power generation in a nuclear power station statement, it is non-renewable. Non-renewable. Cannot be replaced quickly. Uranium, like you can think, as a source, so it cannot be replaced quickly. Or uranium or these nuclear fuels, they will be not available if they are being continuously used. So anyway, you can write this answer, that's not a problem. Anyway, you can write this answer, it will not be a problem. Okay, so what we are going to write now, we are going to write nuclear fuel is used up or will be used up on continuous use. The generation from the waves in the sea, so this is renewable. And the explanation: waves will be always present, water is too much, waves will be always present or available, you can say like this. So my dear friends, if you have any question here, feel free. Okay, stay blessed. Now in the next video we will talk about the thermal physics.